The basic building block of this course, IPT, right? What is the basic building block of this course? What do you reckon? What would you call it? Processes? Yeah? Anyone else want to? Like a building block is the smallest thing that, that makes up everything else, like an atom, I suppose, okay? So you could say like, oh wow, that's smooth. And not a bad answer. Information processing technology. Okay, I'm going to suggest, I'm going to put this. Information processing technology, right? They're a bit like your, forgive me, I've been watching a lot of science videos recently. They're a bit like electrons, protons, neutrons, okay? You can consider them on their own. And actually you can take one of those, people used to think they were indivisible, but you can divide them up into quarks and subquarks and that kind of thing, okay? However, in the real world, right, not in labs, you don't just get electrons flying around doing their thing, or here's a lonely proton. It's like, I've got no friends, okay? In the real world, we have atoms, right? Which are combinations of those, and then they do different things, yeah? So I think if you took your I's and your P's and your T's and you put them all together, what do you get? You get an information system, right? So, I think the system is kind of like the atom, if you like, that we've been looking at through the course so far. Now that we're in communication systems, okay, the atom of a communication system is a network. If you don't have a network, you don't have a communication system, okay? You can't have transmitting or receiving unless there's some kind of arrangement of different, it's a system which can communicate within itself, okay? So if you like, it's a specialized kind of system, yeah? So, we're going to be talking about networks a lot over the next few lessons, so I need to introduce that term. And a few more terms. So let's have a go today at this idea of a node. What's a node? Where would you see the word node in like other fields, or other areas of study? Where else do you get nodes? In your body has a lymphatic system, and that's got nodes, I think. Yeah. What else? Say again. Okay, yep, so when light-emitting diodes, right, they've got nodes in them as well. They're kind of, what are they? Lymph nodes, these things, they're sort of the small pieces that come together to make the network, right? So in our terms, right, what are the nodes, what are the individual pieces that come together to make a network? It's basically any device that can connect to a network. So that means you're all typing at nodes right now, right? If you're typing on a computer, okay? Your keyboard is not a node because a keyboard by itself can't plug into a network, right? But the whole computer can, okay? So that computer is the device that can plug into the network. What other kinds of things can plug into networks and stand on their own? Like a keyboard can't, but a computer can. What can? What else? Good? So, sorry, let's have a little sub-list here, right? So we said computers, which are the main kind, right? We said printers. Anything else that you could plug into a network which isn't one of these? Okay, good. You're all accessing the internet right now, but you're not accessing it through a computer or a printer. Ultimately, you're accessing it through something that can plug into another network, right? Another, like the telephone network, so that's a modem, right? Anything else? That's tricky, isn't it? If we said, say, a hard drive, right? Because I said keyboards, it wouldn't really make sense. Now, a hard drive sort of can, if you provide it with the right kind of extra pieces, right? So a hard drive connected to a network, we would usually call it a file server, right? It's sort of like a glorified hard drive, right? It's a big hard drive, and the computer that it's attached to it probably doesn't have a screen, probably doesn't have a keyboard or a mouse, because people don't need to actually directly interact with it. It's other computers that need to get stuff off it, okay? Just on that idea of servers, right? They're called servers because the point of this device is to serve all the other ones. No one's actually, like I said, no one's actually sitting at the file server or the print server or the proxy server. No one's using those computers directly. They're busy serving other computers. Does that make sense? Okay, So all of these are what we call nodes. Now, that leads me on to the next question, which is, when you connect nodes together, you get something called a topology. Where does the word topology usually come from? Does anyone know? Where is it borrowed from? It's borrowed from geography. What is a topology in geography? Does anyone know? We usually associate it with something like this. Let me see how badly I can draw this. Okay, so something like this. And then like there's something big over here. I don't know. You get the idea. Okay, so I'm sort of looking at some hills and like a sand dune or some kind of mollusk that's gone crazy. Anyway, all right. So what's this? This is we call these contour lines, right? So usually they describe altitude, don't they? Right? We would say this is a topology. This is the topology of some kind of area. It tells you physically sort of how it's arranged, what the important features are, that kind of thing. Okay? Now, in networks, a network topology is just the same thing, sort of. If you like, it's kind of like the landscape. There's a synonym for you. The landscape of a network. Okay? It's how the nodes fit together. Okay. Nodes, if you have more than two, you can fit them together in all kinds of different ways. A bit like Lego, right? You can put one piece on top of another, or you can attach something to the sides, or that kind of thing. Lots of different alternatives, okay? And we're going to look at some of those alternatives. Before we leave off that, I want to remind you of these two different categories. Logical versus physical. Now, when did we study these two? What process were we looking at when we thought about this? Does anyone remember? We were looking at processing. Why were we talking about logical and physical arrangements and their difference when we were looking at processing? Do you remember? There was this idea, right, that you can describe something based on its function. Okay? Missed. Okay, so I could say, look, I have this thing, I actually have two of them. I have two things called eyes. And what's the purpose, what's the function of my eye? It's to accept incoming, what would we call it? It's electromagnetic radiation in a certain spectrum, right, which we call the visible spectrum. And it's meant to come in, and my eyes have the job of interpreting that and turning them into signals, which my brain can understand. Okay, that's the job of my eyes, and to recognize different things around me. Okay, so that's the function of my eye, right? And then you can talk about physically, how does it do that? And you could draw that. You've seen it, right? How does it look? It's got a thing over here, and then there's like an optic nerve, and there's some blood vessels going out here. And wow. I didn't do very well in biology, as you can tell. Okay, so here's my eye from side on. This is the physical arrangement. Yes. Okay. But then I could say logically, in terms of function, the housefly that was bothering me yesterday afternoon has something which has exactly the same function, right? It's about accepting incoming light and interpreting it and trying to feed it to its brain. But its physical form is very different. There we go. Yeah, that's a pretty good one. So, I'm not very good at illustrating, right? But you can tell that this eye is pretty different to this eye, right? So physically, about as different as you could get. At least I hope that's not what you think when you look at me, okay? But logically, in terms of function, they're the same. They're the same, okay? Now, therefore, what does this have to do with networks, okay? I can describe a network this way or this way, okay? All the topologies that we're talking about, they're on this side, okay? How something fits together. Physically, they may look very, very different, okay? So just keep that